Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. So, the precise definition of a limit, and we're talking like very, very formal, okay? So, in my previous video, you would have seen me talk about the limit as x approaches c, f of x equals L. Okay, well, there's a little bit more to that, okay? And that extra is 0 less than the absolute value of x minus c is less than, and I'm not the best at this, okay? So this would be lowercase delta. My Greek letters sometimes are not as on point as they should be. F of x minus L is less than epsilon. Okay, well, really, what does that mean, right? Like, so what? Are you going to use these a lot? No, you're not. But just kind of understanding what they are is kind of a nice thing. Okay, so here we have, okay, and I'm going to go ahead and give us some kind of function, right? I'll extend this out. All right. This is going to be my c value, right? Because x has to approach something. And what it's approaching is L. Okay, so let's say there's a secondary x value. It would have a corresponding f of x value, right? And this is x minus c. So that would be the difference between these two. This right here, that's your delta. And this right here is your epsilon. So let's think about it like this. If you have a measuring device that measures within this much, and say you're measuring volume, and so you have a sphere and you measure the diameter using some type of instrument, you are not going to be perfect in your diameter measurement. So therefore your volume is not going to be perfect. So if you get your measurement within 1/10 of an inch, your volume is going to be within so much of a cubic inch. Okay, so any error created here is going to cause error here. That's what we're saying. Is if you get within this much space on your x, you'll be within this much space on your y. Okay, so they're not always going to be the same error, but we can compare delta and epsilon. Okay, so let's go ahead and look at how that might be. If f of x is 2x minus 5, the limit as x approaches 3 for your function would be, well, if I input 3, 2 times 3 is 6, minus 5 is 1. Okay, so now we know c is 3, L is 1, and f of x is 2x minus 5. Now here's the deal. Because of the absolute value, do I really need the 0 here? No, I really don't, because the absolute value makes it positive anyways. So what we're wanting to do is we're wanting to look at x minus c. It's going to be less than our delta. And f of x minus L going to be less than our epsilon. Okay, so let's simplify this here. I don't want to use that color, I'll use green. We would have 2x minus 6 is less than our epsilon. We can go ahead and say that's the same as 2 times x minus 3 is less than our epsilon. So the absolute value of x minus 3 is less than our epsilon divided by 2. Well, over here we said the absolute value of x minus 3 is less than our delta. So that means our delta is going to be equal to our epsilon divided by 2. So we're within 1 inch here. On our measurement, we'd be within half an inch here on our y. So if I told you delta needed to be within 0.1, then epsilon would be, and we just take 0.1 divided by 2, and we'd have 5/100ths. So that's really the big deal if you're trying to compare your delta and epsilon, is to make sure that you can get a straight comparison on absolute values. Okay, it's kind of like a tolerance. If I can tolerate x within 1/10, then I know that my y will be within 5/100ths. Okay, so let's look at actually kind of a circle, right? I'm going to use x just because we're used to it instead of r. Okay. Find epsilon if delta equals 0.1 miles and c equals 2. Okay. So if I can measure my radius, basically, this is really because x is my radius. So if I can get the radius accurate to 1/10 of a mile, my area will be accurate to what? And we know that'll be in square miles. Okay, so we know how accurate we measured the radius. How accurate is that going to translate to our actual area? Maybe you're measuring an oil spill or who knows what. Okay, and so right now it's at 2 miles. And I'm going to go further into this as well. Okay, before we do it using delta epsilon, let's just go ahead and look. We know at 2 miles it'll be 4 pi. But I might have not been perfectly accurate on that too. It might have been as low as 1.9 or as high as 2.1. That's what I mean when I say my value is within 1/10. Okay, so this would be 1.9 squared pi, and this would be 2.1 squared pi. Okay, so we'd have 4 pi minus 1.9 squared pi, and that's off by 1.225. So the difference here is 1.225. What about the difference here? And I know when I subtract it'll be negative, but it's still, that would just mean I'm over. So 1.288. So we can see I'm off by about 1.3. I'm within 1.3 based off of this right now. Okay? So let's use the formal definition. The absolute value of x minus c is less than delta which in our case was 0.1. Okay? And I'm getting that from right here. And I'm using my c-value of 2. Okay. The absolute value of f of x minus L is less than epsilon. And that's what we're trying to figure out. Okay, so the first thing I'm going to do is I'm going to factor out the pi. And then I'm going to write as x minus 2, x plus 2. Okay. And the reason I did that is if I factor out the pi, I have x squared minus 4, and we know x plus 2 times x minus 2 is 4. Okay. We want x minus 2 in there. That's what we're comparing. So we need to make sure we're comparing apples to apples. So the absolute value of x minus 2 will be less than epsilon divided by pi, absolute value of x plus 2. Okay, now we are at an x value of 2, so we'll be approximately epsilon divided by pi times 2 plus 2 is 4. Okay, so now we can substitute the 0.1 here. Okay, so epsilon will equal 0.1 multiplied by 4 pi. So let's check out what that is. $1.2566, which is actually in between what we have here. So epsilon is approximately 1.2566. Okay, so in other words, we will be within, and I'm going to round, approximately 1.3 square miles. Okay. Now, I want you to keep in mind, anytime you have the absolute value of x minus c, it is equal to the absolute value of c minus x. So if you're going along and you're working with these and you're trying to force the delta and epsilon together, know that you can kind of go ahead and you can kind of force that out.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.